When we design a beam or column or any member of the structure, we normally adopt from the standard shape that already available in the industry. So let's go to some of those standard shape. Standard shape, and that basically in appendix C of the book in both US customary units and also SI unit. So before we go to detail to explain, I want you to demonstrate with one time of the standard shape, and then we will get back to the lesson. In front of you is an example of standard shape when we design a beam or column. So for this one, as you can see, cross section, in this case, a Y flange shape, and that portion we call flange, that portion we call flange, and when it Y, we call it Y flange. And then if it smaller, then we call it American standard. For this one, and then the middle one, we call it web. And as you can see, the thickness of the flange and the thickness of the web don't need to be the same. And when you design for the beam, you look for the size of the standard shape. In this case, for example, the Y flange. So there are two components in that initial for the standard shape in the Y flange. W, for example, W 2144, 21 by 44. What does that mean? 21 is basically the nominal height or nominal depth of that member. So measure from the bottom flange to the top flange. And then the second components that is 44 is mean the pounds per linear foot of the member, pound per linear foot. And of course, it applies the same for the SI unit when you also have W. The next one, it will be nominal depth in SI metric system, and then nominal weight kilogram per meter for that members. And as you can see here in the appendix C of the book, we have two area moment of inertia. The first one is X that go in the middle of the web, and the other is Y. It go to the parallel to the web and in the middle of the web but parallel. The other one is perpendicular, that is IXX. When you get in the appendix C, keep that in mind. This is IX axis go through the middle, perpendicular to the web. Y, if you get the appendix C, it will be go through the web but parallel to the web in the middle there. That is Y axis. And for the beam and for the table in there, you always see the IX, the area moment of inertia about the axis perpendicular to the web, always greater than parallel to the web, the vertical one. So for that reason, it's greater, and you can see the equation for the stress is equal to MC over I. So whichever the I position is greater, it will create less normal stress. So for that reason, if you go back to see the Costco, go to Costco warehouse or Walmart or Publix, etc., you see the beam on the roof, it always lay this way, because this side create a better area moment of inertia, greater area moment of inertia. It means that less stress on that body with the same moment. If we put the beam that way, it tend to be less, because this is IY, and you can see, and that will create more stress on the body. With that demo, we can now write out a few Y flange shape and explore further in appendix C in there. So the first one that we mentioned in the demos, that is the Y flange. The Y flange. So basically is cross section of that member is something like that. If you're not sure, you can get back to the demo to see that one. And that you can see everywhere in many applications that you can see, even in the warehouses, or go to Costco, Walmart, or Publix, etc. Look up the ceiling, you will see that. And in that it have, for example, go back to here, appendix, they have, as you can see, W36 by 300, etc. What does that mean? So in here, what does that mean? So we have W, what is the number we're talking about? 36 cross 300. So that the first number that I mentioned in the demo, that is a depth, and 300 basically 300 pounds per foot, of the member. So that what it means. W stands for wide flange. The other type of cross section that I also mentioned in the demo, that is American Standard. In American Standard, it's similar to the wide flange, but it's smaller in the width, smaller, just like that. It's here, that American Standard. So if you have that in here, in your appendix, you also have an SI unit. You have the same symbol, right? W920, which is the depth in 920 millimeter, 446 kilogram per meter. And then if you continue, wide flange shape, same appendix B, and now you have American Standard shapes, S. So S stands for American Standard shapes. And for example, here S24, 121, what does that mean? So we have here S24, 121, S24 by 121. Again, it's also just either 24 is the depth, and 121 is the pound per foot. And then we also have other shape, which is channel. And in the channel, we have something like here. And yes, it have it in your appendix C. And then we also have angles. And channel is start with the C, for example, C12, 75. So 12 stands for the nominal height or depth. Of 17 stands for the pounds per linear foot. And then the angle is have an L at start. And then it will be 5 by 4 by half. So it more parameter in the angles. So what is that? Here, the size is the first two. The first two, we're talking about the size. Okay, so for example, the angle, it don't need to be same at the, for example, here, that side, these two sides, side 1 and side 2 are the first, right? For example, this is 5, this is 4, but it's nominal. It's not exactly the actual, not 5 or 4 inches. And that basically nominal. And then the last one, the same, that either they don't talk about the weight, but in this, it talk about the thickness. nominal thickness of the angle shape. So keep that in mind. So let's go back to here so that you be familiar with when you read. So this is the American standard shape. If you continue further, appendix C, still standard shape, C shape, and you can see that it channels, and they have, for example, 15 by 50. So, and that in here, what is the nominal depth and what is the kilogram per linear foot. The last one that we are talking about is the channel, and apparently we don't have it in here, but that basically for the angles, it will be that what they define for the size. And I also have, as you can see in here, with different beams, S-beam, which is standard, American standard Y-beams with the Y-flange shape, neutral axis in there. C outermost fiber, so as you can see there, it opposite to the rectangle shape that you have there. So with that, the different shape, even with the same areas, for example, keep in mind here on the, just give you some extra in here, keep in mind, for example, for the two rectangles, the wood, for example, here, 6 by 4, 4 by 6 is 24 inches square. And then the other one also 3 by 8, 24 inches square. But if you design the beam, if you recall the area moment of inertia for the rectangle equal to parallel perpendicular cube divided by 12, then the one on the right, which is 3 by 8, would have higher, greater I about the x-axis. So with that, when you design the beam, it's better to even the same material, same economic, because same square cross area of the cross section. So it means that you buy the same volume. But if you design something like on the right side, then it will can get more load compared to the left side if you design for the beam. But of course, it will compromise. As you can see on the other side, 6 inches. The right side, 8 inches. It may compromise with the effective height of the building, etc. So all of that should be considered, and similar to the standard American standard shape or the Y-flange. With that, go back to practice worksheet AC and 8B.